Right, while I'm waiting for the freezer spray and the capacitors, I'm going to turn my attention to the lid. Just because, well, I figure there's a good chance we may be able to get it working, even though I'm not that confident. That may seem crazy. Yeah, that there's got a spring, so the drive pushes it forward like that to our position, and you can eject the disc. It's quite nice. These buttons work. There is a piece of plastic I taped to the side of it that came from somewhere. I can't actually see it anywhere where it came from. Anyway, you can see we've got a warranty seal here that needs to come off. I'll leave these 3 stickers on. Obviously, we need to leave that one on. We've got a sticker on the front here. Some sort of stock control thing, can peel that off. So I'll use a bit of WD-40 to try and get that off, I think. We've got this thing here, which again was on it when I bought it. Processed by GW, whoever that was. Does the machine into BIOS? Yes. License attached to case, not applicable. Sockets 1, Pentium 3, 500 megahertz. Number of SIM slots. What's that say? SD. Oh yeah, it's got SD RAM. 3. So 128 meg, 20 gig hard drive, IDE. Motherboard, manufacturer. Speakers, none. And then it's just there 2 unused ISO slots. It's quite nice, isn't it, really, that it's got a couple of PCI slots and a couple of ISO slots. No AGP slot though. I could have sworn AGP came in around Pentium 2. I'm sure mine's got an AGP slot, but I could be wrong. Yeah, you can see that bit of plastic I taped there. I don't know where it's come from. You're thinking one of these clips maybe on the front, but I've inspected and I can't see anything anywhere. Anyway, we'll keep those bits of plastic for now, but I can't tell where they've come from. We've obviously got loads of stickers here, pat testing things and stuff like that. That's the original part number with the what's his name, service tag, so we'll keep that. We can enter that back in the BIOS after. Another serial number barcode asset tag here, one here, and obviously all these black marks and things all over it. So we'll start with the WD-40, I think. It should be safe to use with something like this. So let's just get a little bit on the paper towel and start to try and massage an edge into this. You can see it's starting to peel up here already. Anyway, I'll report back in a few minutes. My first thought was there that that's still got some sticky on it or something, but it isn't. It's seamless here. It's absolutely seamless. So that is kind of the original colour. It's faded a bit there, but I think that label was ripped, wasn't it? So some light has got through to that part. Anyway, we'll clean it with plastic cleaner and polish and all that sort of stuff later. The next thing I was going to have a go at is this here. So we'll try the WD-40 again. I don't know whether this is going to work on that or not. Those warranty seals like that can be really, really, really difficult to get off. That's looking a bit better, although it does stand out like a sore thumb, doesn't it? Just try and clean these bits off here. Yeah, this is where bicarb soda, I'll move on to bicarb soda next, we'll get any little marks like that off the top there, but you can see that's not too bad. And onto this side, so I'll start with the good old nail, just to see if we can carefully peel what we can off there. I know it's very dark, you can't really see from that angle, but these ones here are traumatic. I've been at this for 20 minutes trying to get these ones off. So I'm having to get my nail right onto the edge of the paper towel and literally force it. WD-40 and IPA have the same effect. I haven't scratched the plastic at all, you'll see in a minute. The plastic looks good as new. It must be brighter than the surrounding area. Yeah, as much as I didn't want to, that last bit there, I removed it in about 20 seconds and the rest of it took, I don't know, 10 minutes. And I just used this, I didn't want to, but I just got in here really low and then just went like that and it peeled off within, let's say, a minute or two, the whole lot. Really easy. And I used soapy water. So hopefully I haven't scratched it. And then the final thing now is to use some bicarb soda, which I've got nearby, and the soapy water, and just try and clean all these blacky marks and things off. Some of that label there's gone, but Yeah, so I like all this stuff here. That's sticky. Yeah, a bit of bicarb of soda. Just sprinkle a bit there. Don't need a lot, I don't think. And soapy water. That's like 95% water, 5% washing up liquid. Bit of paper towel. Get a little bit of abrasion with the paper towel and with the bicarb soda, and hopefully, yeah, they're coming off. They're coming off. You can see here it's looking a lot cleaner. So I've got some bicarb soda there, a bit of water again. You can see that's pretty much gone considering how deep it was. Right, so the capacitors here, got Nichicon 3900, 6.3 volts. I was trying to find the hole in that bag. There wasn't one that's sealed. Yeah, they were in bags of 10, so yeah, they look genuine. So these should be alright. Yeah, I'm going to recap it anyway. Is this going to fix the problem with the temperature? I seriously doubt it. I seriously doubt it. I mean, they look alright, but these are the caps that I've seen go bad on lots of Dell boards. Same brand. So is these green ones with, I think the Sanyo, aren't they, or something. I need to be careful I don't break these plastic clips off here. So I'm going to start with the one down here, I think. I'm going to use the solder pump and the Heiko. Just going to set the Heiko a bit higher. I'll try 445. It's a multi-layer board. It's going to be 6 or more, maybe 10 layers, 12 layers, I don't know. I would imagine. Certainly more than 6, I would think. Seems to be melting alright. So yeah, we'll have a go with this. It had some WD-40 in it last time I used it, and that made all the difference to this pump working exceptionally well. So let's just see, is this going to be easy or painful? A lot of the time when recapping PC motherboards, it's traumatic. It is usually very difficult. Oh, that's come out. And that's come out. Wow, pleasantly surprised. I didn't pay attention to where the ground was there. Yeah, the white band on these indicates the positive. Can you see that? So, well, according to these ones it is, because I can see the white extending on the positive. So, that's an interesting one, isn't it? Usually indicate the negative, not here, they're indicating the positive. I'm just going to test that. I'm expecting these are all going to be alright. I really don't think this has got anything to do with the temperature issue. It's going to be something built into a custom, maybe. I don't know. Because this is the thing, I don't have any clues as to how it's going about doing this temperature measurement. Is it the core? And the obvious one is voltages, you know, the self check voltages. I should be measuring the core voltage to go, do we have the right core voltage? Because if you've got too much, then that would overheat it. Yeah, look at that, really good ESR. Okay capacitance. I don't think these caps are going to be the problem. You've got to do this anyway. Just part of the course, I guess. But what I was going to say is try and measure the core voltage. Where do you measure that? There's no test pads or anything. I could trace it here to find where it is on the MOSFETs. I tried measuring around a little bit on the MOSFETs, but well, that was proving very difficult to do. Because I was really nervous about shorting something. And this is the thing, when connections are so small on a lot of these things, the last thing you want to do is short two connections while you're trying to measure something. Trust me. So the band is the positive on this board. Anyway, they're going to be alright. I feel a bit happier at having these caps on it anyway. I was going to say, confidently, when did I ever last not get a board working? But you know what, I have low confidence on this board. Just because there are no schematics, and I have no real clues as to where this temperature problem is coming from. soldering really well as well. There's a lot to be said about slightly older boards. There's a lot to be said about slightly older boards like this Pentium III here versus, you know, a modern Dell board. It's obviously not got quite as many layers as something manufactured in the last 10 years at least. The last couple of Dells that I've recapped for my job, for the office servers, they were painful to swap the caps on. But, well, this is looking like this is going to be a breeze, isn't it? Like a 10-minute job. The only reason I could see one of these creating a problem with the temperature issue is if it was failing to smooth one of the power rails, and the power rail was compensating, going up and down, up and down, up and down, slightly over voltaging something somewhere. That's my theory, but I can't see this making any difference. Again, positive to the... hang on, why is that not unblocking? Yeah, it's one of these where it's unblocked, but it's not quite unblocked enough to get the leg in. Just push gently with that. If your board's not on a flat surface like this, be very mindful of things rolling down it. I'm talking about particles of solder. It's 2 down. Anyway, I'll report back. Yeah, I decided to clean up as I go along here. But it allows me to inspect just to make sure I haven't damaged anything at the same time here. So I'm getting there. It's only taking about 15 minutes-ish to get to the stage. I've got 2 more to go. So another tip I'll give you, this one here, got on this pin I'm soldering there, there's traces to above it, you know, the above side. On this one here, there's traces below it. So try and heat, if you can, from the side where the traces aren't. You can't always do that, because sometimes there'll be traces on both sides of the cap. But the point is, if you were to slip when you're using the desolder pump, or apply too much heat for too long, you're not going to burn up the fine traces that run by it. Yeah, you know, you've got like data connections, address connections, control signals, etc. that run across this board, and yeah, just mitigating damaging them really by staying away from them. So all the other caps have been relatively easy, but there were 2 that took. We've got these 2 here. Can you see the ground pour around this area? It's quite a large pad. The side that's connected to that, I think it was this side, the bottom pins on both of those caps, I must have had to heat on that point for 30 to 40 seconds at 455 degrees before it was molten enough to free the cap or to remove with either flux and braid or the solder, you know, the solder pump. Just cleaning those again. I don't really need it anyway, so that's the one we've done here. And obviously inspect you haven't damaged those fine traces that run right next to the things, or knocks anything off. That's another one. I recapped one of these from my boss, you know, one of the Dell servers at work, about 5 years ago, and I was inspecting with magnification, and I realised one of the caps had just got knocked gently, and it lifted off and pulled the trace with it. Now I was able to fit it back down again and join it back up, but that was literally just a touch. I just touched it with something, I can't remember what, maybe the solder pump, and there was no actual damage to the board. It's just literally the trace just ripped right off with the component and the pad, just from a little gentle knock. And I was horrified, to be honest, because, you know, you'd think, well, it'd need fair knock, wouldn't it? That's what you'd think. I would have expected I would have had to whack it with something really hard, use some force, and I didn't. I just literally touched it. So these things are very fragile. And it's because the SMD cap in that case was, you know, such a tiny thing. It's like this size, like, or smaller. You don't need much force to wrench its pad off, that's for sure. So yeah, everything I've tested so far has been good. So you know what, I'm calling it now. These caps are going to make no difference whatsoever. They're only cheap though. It's like, I don't know, £2 or £3 for a pack of 10, which is not bad. Capsule usually costs you a lot more than that. And if you've leaked, obviously clean underneath them, but it's spotless, this board, really, in terms of the caps. And I have tested every one apart from the last two, I think, and every one of them's been fine. Like, good as new specs, really, in terms of readings. ESR, excellent. I think if there was a capacitor issue on here, it would be a slightly shorter tantalum or a ceramic. Maybe affecting like V-core or something. I don't know, like maybe it's overcompensating because the voltage is too low. So it's like going up, down, up, down, up, down. Could be something like that. I don't know how I'm going to prove that. I mean, the thing is, it's a whole different ballgame working on PC motherboards to these retro systems that are 99.9% of what's on my channel. You know, a retro system with its dual layer board, you know, when I talk about things like Commodore 64, Spectrum, CPC, far flipping easier than something like this. And of course this is the realm of, you know, getting into VGA, way more surface mount parts. And I guess for me, this is the end, or was the end of the golden era of PC. You can argue it's still in its golden era now, but it's like going in further and further into a golden era. But what I mean is, I have a lot of nostalgia for everything up to this, you know, the Pentium 3 and the Pentium 3. And then beyond that, it all starts to get very samey. You know, AMD seemed to rule the roost at that point, didn't they? With the, what's it called? Was it an Athlon? Yeah, it was the Duron, the Athlon, didn't you? And that's where it started to just get a bit samey. I went through the different speeds of Athlon, as I'm sure many other people did. I don't know, there was like an 1800, there might have been one slower than that, 1200, 1800, and 2000, and 2200, and 2400. And then you got into the Athlon 2s, and you got into the things like the claw hammer. I had fond memories of the claw hammer, because you know what, that was a really high performing chip at the time. Well, I think it was. It had a really big cache, and it was great for gaming back then. I think I even played Crisis on that when that came out, and it wasn't too bad. That was before I moved on to quad, you know, duo, quad core, extreme, whatever it was called. But you see, around that time, at the Athlons, you know, just after the Athlons, people were starting to move to consoles. They were. Everybody I knew had got an Xbox, and I ended up getting an Xbox. And then I just followed on really with the Xbox 360, and eventually onto PlayStation 3s and 4s and stuff. But that was really only as a part of my channel. Yeah, there was something unique about PC gaming around this point and before this point. You know, your Sound Blaster cards and your GPUs, they were all just like amazing. With each new revision of something that came out, you were blown away with the performance and the features and the functions and all the rest of it. That stopped happening for me really just after that period. You had nice graphics cards after that. You know, graphics cards continued to wow people right up until today. But you see, that's for me, I think when you look at gaming, that's the only thing that's left in gaming now. Really, it's just about the GPU. It really is. Yeah, there's lots of different CPUs and lots of different motherboards and things, but it's like, like sound cards, for example. What sound cards does anyone have? I don't even know what I've got. I'm using the onboard one. It's pretty blooming good, actually. It does everything I could possibly want, but I don't know what it is, because it's very similar to hundreds of other sound cards out there now. Sound cards did continue to evolve, but not in the absolutely mind-blowing, shocking ways that graphics cards continue to evolve. And you can argue that's slowed down. So yeah, the benchmarks reflect that, yeah, with each new generation, they're, you know, 100% or more faster. The point is, though, everything else hasn't really caught up with it. Are game developers really fully utilising absolute top-of-the-range graphics cards? I'm not sure. Things like Cyberpunk certainly did, and that Indiana Jones game that came out that I can't remember the name of. And I'm sure there's lots of other examples where they are absolutely pushing the technology to its limits. But yeah, it's just not the same as like when I got Rebel. Was it Rebel Alert or Rebel something on the PC? It was like one of the early CD-ROM games, and you needed a dual-speed CD-ROM drive, and I got a dual-speed CD-ROM drive, and that difference of going up to something that's twice as fast, you noticed it. You absolutely noticed it, not just because the game worked. Seventh Guest was another one that really needed a dual-speed CD-ROM drive. And you can argue with every CD-ROM drive after that, up until about, 8 or 16 speed, again, it was really cool that you double, or more, quadruple the read speed on your CDs, and you'd notice it. It was noticeable. Look at Blu-rays and DVDs these days. Do you really notice when you've what speed are they? I don't know. I don't know what speed Blu-ray is these days. A typical one you get with a PC. You probably don't even get them with PCs anymore because everyone's trying to get away from optical media. Yeah, so lots of fond memories of everything before and around this era. And then some, don't get me wrong, fond memories afterwards as well, but it's just not the same. It's, I can't imagine you're going to see me and my child collecting Athlons, for example, because, well, I'm just not that passionate about them. So there we go. That's all of those big, bulky 3900 microfarad caps replaced. I'll have a little inspection here, but I'm just going to gently brush over it. You can see there's just a little bit of flux there, some streaks and trails and things that just need wiping off. But I'll have a quick look around and we'll get it back in the case and see it behave exactly the same as it did before. So then it'll probably come back out again, and I'm going to need to have a sniff around, try and find something that might be sensing the temperatures, and I just can't find it. I've looked over this board for hours and I can't find anything. Can't see a PTC or an NTC. Right, the good news is we've got failure. That's keyboard failure, I think. I haven't got the keyboard. Yeah, it is keyboard failure. I've not got the keyboard plugged in. Don't need it. It's set up to just load Doom, which means I don't even need the keyboard anymore, which is a good thing. Just for testing, and we'll just wait to see if we get a thermal shutdown. I'm sure we will. If we don't, the only other thing I did is blow under the CPU slot like a few different times, different ways, just in case there's some fluff and a sensor under there and some dirt or something. I seriously doubt it, but I don't know, I'm out of ideas with the temperature thing. It's powered down after, 2 or 3 minutes on the first power on. I powered it straight back on. It's been going now for about 10 minutes without an issue. What I was going to do is test this fan. Hang on, I've got a connector here from Ian Scott Johnston. He's got give me a bag full of cables and sockets and adapters and everything. Massive thanks for that, Ian. And some memory as well, actually, for different generations of PCs. So I'm very grateful. But I thought I'll test a fan I've got here and stick this sat here facing the heatsink, because I don't think you can see, I'll show you in a minute, there's a plastic clip down here on the motherboard and one down there designed for a shroud. There should be a piece of plastic that comes from Dell that goes over there, yeah, and maybe slides on this way or something and clips onto those two things. I think, I could be wrong, and I'm just wondering if this functioning fan here is just not, it's a bit feeble without a shroud over it, so that maybe the chipset where there's a big black heatsink on down there, that's what I think that is, the chipset, or the CPU, one of the two, is actually genuinely overheating. I don't know. Or is it a case of when the board's cold, it overheats more, get this right, and when it warms up, it stops having the issue as much. And I think that might be the case, because when I tested this last time, it was January, I don't know, 12, 18 months, 2 years ago, actually, 2 years ago. It's freezing in here, and it was, failing for the first 4 or 5 minutes. Kept power cycling it, and it lasted longer and longer and longer. And when it warmed up, it stopped overheating. So there could be a bad connection somewhere on the board. Maybe there is a PTSC or NTC somewhere, and a resistor somewhere, a dry solder joint, or the component tolerances are changing when it warms up, and then it starts to behave itself. But when it's freezing cold, you get a fake, thermal shutdown event occurring, because of it being cold. It's the irony, isn't it? It's like it's overheating, but it's not. It's actually the opposite. It's too cold. We need an error message that says motherboard too cold, needs to warm up or something. I don't know. But right now it's not failing again, so I can't have my fan theory, can I? Maybe I can if I had the fan there, but then I'm going to go around in circles here. And what I was going to say is if I start cooling things down now and the problem comes back, that might be an idea actually. Try freezing around things and see if we get a thermal shutdown. This freezer spray makes me laugh. It says like extremely flammable, highly explosive. You know, I actually think it's butane or something. I really do. It's come from Poland. I actually think this stuff's butane. Because if you know anything about butane, you spray it and you get a massive amount of cold coming off it, freezing. And I've just got this theory that that's what this is. I hope it's not going to explode me spraying this around. Let's just try and spray the main heatsink down there. Let's see if anything happens. Nope, still running. Leave it a minute. Spray around here. See if anything happens. I'm just like trying to target one area at once, but I mean, we've got an overheating situation. Freezing something down, what you would think would not give us a problem, but it seems to be behaving the opposite way. The opposite way to what you expect. Let's just freeze down there. Nope. Further up there. Nope. I mean, it's like, where would you put a PTC on here? You'd think it'd be round this. Maybe around the main custom there, that's chipset. Like North Bridge or South Bridge, I forget which. I always get the bridges mixed up. Crystal, I think in the middle, oscillator. Crystal chipset and Ethernet. Don't know. Bottom bit down here. Anyway, I'm just going to leave it for a bit now because general spraying around a few areas there, it's not had any effect at all. Right, it didn't thermal shut down, but I've just put this fan there anyway, blowing towards the black heatsink down there and this. So you know what, we've got some additional cooling. Let's just see. I'll test this for a period of time now and I'll report back if we get a thermal shutdown. I'm going to switch the heater on because it gets really warm in here and just see if that makes anything happen. Literally 1 minute after I turn the camera off, it shut down. So this is the thing, it just doesn't make any sense, does it? There's that much air around here now, I'm freezing even though the heater's on. I can feel the cold air coming from the PC. So it isn't a genuine thermal shutdown as far as I can see. I need to measure the V-core down just to make sure it's not slightly over voltage in the CPU maybe. But I wouldn't have thought so. You see, this board is rated up to a 500 MHz Pentium III, and that's what's fitted. We've ruled out the actual Pentium III itself, unless there is actually just a fault with the V-core. You know, but let's say you said about putting 2 volts, it was 2.3 volts or 2.2 volts. Well, yeah, then it would overheat. Maybe I need to try and get some software, maybe something that came with this, like some Dell management software or something, see if I can actually report the CPU temperature. Right, getting nowhere. I think what I need to do, a couple of things. I need to measure voltages on the VRM down here. I think this is what this is for here. Because if you think about it, that would make sense because we've got 5, 3.3, 12, minus 12, etc. coming here, yeah? And the only other voltage, and you know, 3.3 as well, the only other thing the board needs is CPU core voltage. And this is what these MOSFETs here are doing. There are a number of things I've struggled to find out about this. So like this ICS chip here, I think they were bought out by Renaissance, I can't even say it. It's that time of the day. Something beginning with R. Stick it up top left. Renaissance, I can't even do it. I don't know what's going wrong. I don't know what's going wrong with my brain. I can't say it. I'll stick top left there. The bottom line is that chip there is a clock control chip. Yeah, makes sense. There's a crystal here. It's right next to what I think is the South Bridge. I always get confused between South Bridge and North Bridge. I'll correct the annotations if I'm wrong. And then a PCI, by the way, PCI, it says PCI set or something, PCI chipset. And then over here we've got the graphics card, obviously, GPU, and then I think we've got the North Bridge right next to the CPU here. We've got another one of those ICS chips here. This one here is DDR buffer, it says, buffering. And then we've got some 7.4 series in a few places, quite a few places, smaller ones, a little 7805 down here. Another crystal. This is the audio section and modem. That's a relay. We've got, where's it gone now? A TAPI connector. I was like, what's that? Temperature? No, it's not. TAPI is telephone API. So it goes with a modem. You know, it could switch your voice on and off and send. You can actually output your sound through the modem. You could, you know, set up, I don't know if you remember, but you used to be able to set up like a telephony system on your PC so that it would, you know, with an automated, you know, press 1 for something, press 2 for this, press 3 for that, and you could do that using the TAPI and interfacing the sound card into the modem and have the modem answer your calls. Quite clever, really. And then back, what else have we got? Well, I think loads of 7.4 series here, just buffering and stuff, probably slot related, I would think. And for these, you got IDE 0, IDE 1, floppy drive, I think. I'm not sure what that is, now I think about it. Because if that's floppy drive, what's that? AMC, it says on it. I don't know. Maybe that was a diagnostics port. I might just have a measure along there. I can't think what else that is at the moment. So, what does that leave? Well, down here, I was particularly interested in the stuff down here, because this little AD, analog devices chip, it's got that little play symbol. You'll know what I mean. It's like a little arrow pointing to the right. I'll stick a photo of that chip. 51039, and I was thinking, is this something to do with it? Is this like a thermal something or other monitoring the temperature from the slot, you know, from the signal from the processor? But I don't think it is. I can't find a data sheet on it. I actually think it's the best I can determine from its location and some of the other components around here. We've got 339s, comparators and stuff. Yeah, LM393, that is 393. I think it's a multiple voltage monitoring device, and I think that this is monitoring the supplies of different levels. There's one up here as well, another 39, which is or 393. No, there isn't. There's a 431A. I think that's a voltage monitoring device. I found a few of those. It's, you know, a voltage reference. Voltage reference is the word. So there's one down here, one up there, another one there. There's a few of those voltage references, which makes sense. You know, it's like comparing against the input voltage and going, is this 5 volts? Is this 12 volts? Is this 3.3? Is this whatever? You can see we're running out of chips so far in terms of, you know, working out what might be some sort of cores other than the CPU slot. And then these here are RAM, and then you've got an expansion here for the RAM, video RAM. That's video RAM, that is. And the SIM, take that out, clean the contacts on it, inspected it. I did look to see are there any thermal monitoring capabilities on the SIM. And then I think it's like an Occam's razor again. It's back to basics, isn't it? It's got to be the slot. It's got to be the CPU. The CPU, we know, has a thermocouple designed into it. Now, just looking at the pinout, it's the 15th slot down on the A side, which would mean on the long part here, it's the 15th one down on this side. Now, the thing is, you can't really do any connectivity, can you? Because everything's in the way. I don't know where that goes. I can measure from it, and of course, we can't measure under the North Bridge here to see where it goes. You know, try and do that. It's BGA mounted, that. And it looks like it's a BGA package, you know, like a PCB. That's why it's a weird shape, with a couple of chips on it maybe, and components. But that heatsink is welded on. I don't want to try and prise that off because it's BGA mounted, I'll damage it. So I think the next thing I'm going to do then is get it back in the case and have a measure around on these MOSFETs to see what voltage we've got on there. Because that, I suspect, might reveal a clue. Let's say it's 2.3 volts. That's going to be too much for our poor Pentium 3 here, and that would answer the problem entirely. and it wouldn't give me the solution, because I'd then be in the case of, well, why have we got a slightly higher voltage? And that, I don't know what that could be. That could be a number of things, but I'm guessing that is what the issue is going to be. The other thought I had is we could mask out on the CPU itself the thermo pin here, yeah, but I'm only going to do that, so in other words, mask it out so it's not connected to the slot when you put it in, and as far as the BIOS is concerned, it's going, I'm getting 0, 0, 0, it must be alright, 0, you know, I'm getting no signal from the thermocouple there. Green light, no thermal shutdown, and maybe it would continue to run, but I think that would be foolish to do until I've checked the vCore, because if this was overheating because of the CPU, it's got to be the vCore, and the only way, well, it's two things. It's either the vCore or the clock speed. It's been overclocked. So even though the jumpers here is set to 500, we'd try lower positions. I tried right down to 266, and it's still thermal shutdown. So unless the clock generation stuff is not working, and maybe it's running at 600 or 700 or 800, it's like double. It could be 1,000. It could be 1,000 megahertz or something. Because it's not out of the realms of possibility. But then again, I don't think the cache RAM on the chip that goes in here, the board that goes in here, would run that fast. I don't think you can overclock those to 100% at all because of the cache. And it's an external cache on this type of slot one, I think. So, I don't know whether I covered it, but we will do when we look at some of the other Pentium 3 teardowns I'm going to do, the actual, the slot one themselves. You've got the Pentium chip, the Pentium 3 that is, and a RAM chip on there, external. So, yeah, I don't think you could overclock that to 100%. And if it was just doubling because there's some division problem going on, when we had this set to 266, well, that's not far off its original specs. It shouldn't be thermally shutting down at 266 if it was double 266 to 533 or whatever, if the maths is right there. Yeah, anyway, so I'm going to get that back into the case, and I'm going to measure around here. The hot and cold thing might be something I might turn back to as well. Heating an area and see if we can get it to thermal shutdown on a consistent basis. But then the very nature of how this is doing this issue is, a bit hit and miss as well. It's like it can thermal shut down 30 seconds after you first switch it on, and then you switch it back on again, and it's alright for 5 minutes, and then it shuts down again, switch it off, switch it back on, it's alright for 20 minutes, and that is a puzzle as well. The only thing I can take away from that is if the power's alright, the clock's alright, and the CPU is actually okay, then it's something about the sensing of the signal from pin 15 here, and then by disabling it, by masking tape, masking the pin off, putting it in, that can completely solve the problem, because it's never going to thermal shut down. But that's slightly risky. And I guess maybe before we do that, we should get some software on there to show me the temperature, so that we can actually monitor it and see what's actually going on with that temperature of the core. And is that even why it's shutting down? It may be that something on here is getting a signal to say thermal shutdown, we need to shut down, but the actual temperature is okay on the CPU, and there could still be some sort of thermal thing in one of these devices here. I don't know. This is just a nightmare. It really is a nightmare. I really wish the service manuals would be pushed out for these. So you can just about see the multimeter there. I'm just going to measure what I think is the vCore. So we've got two MOSFETs here, 2.05. And I could monitor that and wait for a thermal shutdown, but I think that's vCore. It can't be anything else. And there are two of those MOSFETs here showing the same thing. Hang on, if I get onto it. Yeah, that one shows 4.97. That shows 4.97. What does this one show? 2.53. So we've got two MOSFETs where on the main tab, the large tab, that's what we see. We see 2.052-ish and 5 volts on the other one. But why would you have the MOSFETs on there for 5 volt, generating 5 volts? Unless it's got an independent 5 volt rail for something that's coming from, well, I don't know, that wouldn't make sense. Let me just have a look at one of those 5 volt MOSFETs again and probe a couple of the other pins. So, like, we've got, this is the first MOSFET, 4.53. Then we've got what? I'm not sure what pin that is. And then the other pin we got ground. And that's what I don't get. We've got a couple of MOSFETs that measure that way, which is, to me, is a bit strange. If I have a look at the other MOSFET here, let's see what this one shows. 5.82, and then we've got the 2.53 out. So that one, I would say, is coming from the 5.8 something volt rail, whatever that is. I don't know, this must be 2 stages or something. The voltage has been generated somewhere. I think there's about 6 volts, and that's been then PWM regulated down to 2 point whatever for V-core, I think, because, well, that 2.05 there, that's got to be V-core. It's what this CPU is rated at. I mean, it says it's 2 volts. Oh, you know what, that's going up, look, 2.07. Maybe we have got some issue. Maybe we need to monitor this and wait for a thermal shutdown, because maybe it will jump up. We saw 2.07 a minute ago then. Or 06, 07. I mean, is that really enough to stress out a Pentium 3? I need to look at the specs. I think you can go up to maybe 2.1 volts. Anyway, I'm going to find a way to monitor that. Let's just set that there. Yeah, so it did shut down again while I was monitoring the voltage, and I didn't see it go over 2.07, which is what I expect at. So I don't think voltage, let's do it again, I don't think voltage is an issue. The one thing I did notice, I was noticing the jumpers down here for choosing the you know, the CPU speed in general, and from that, I guess it can automatically at BIOS level work out which revision of chip it is and what the divisions are to get the core speed and stuff. But you've got, you know, jumpers for 500, 450, 400, 350, 333, 300, 266, and then I noticed bus 66M. That's not set, which means it's going to be at 100 megahertz. Now the front side bus on this is supposed to be 100 megahertz, but I'm just wondering if there's a problem there. That means the front side bus is glitching. We're getting, not glitching in such a way that it crashes the system, but it's slightly faster than it should be. So maybe I should just put a jumper on that and try the front side bus at 66 megahertz to see, is it any more stable? Well, we think we know V-core's alright. I don't see any of the passive or active components around the V-core stuff. There's some tantalums. Maybe I should measure, I might do that next. Measure those tantalums. There's some around here and some here, just to see if we can find one tantalum on the V-core. Maybe that is just, I don't know. The thing is, you see, you'd think you'd see it when you're measuring it, but you don't need very long of an increase in voltage that won't register on the meter for it to class as an overheat, probably, I think. So that's the thing, you can be measuring with a multimeter and be oblivious of the fact that you are getting the occasional, certainly just as it shuts down, the occasional jump out of the range of normal operating voltage. I mean, I'm clutching at straws really, because you know what, you think there'd be a certain tolerance level there. I tried forcing the front side bus to 66 megahertz, it didn't even boot. So, I can't even do that. The motherboard is ignoring that, but what you're doing is you're forcing the south bridge here to 66 megahertz, which means you've got a problem, you've got a difference in speed. That might be why it wasn't booting, because the north bridge down there is going, identifying the chip and going, it's 100 megahertz front side bus, and maybe it just is 100 megahertz front side bus. You know, you can't change that. I think maybe I could be wrong, because I think maybe the north bridge would be in control of that. So the only reason I could see that being a feature, that jumper, and the lower clock speeds, is for the Pentium 2. Now I do have somewhere some Pentium 2s. We could try a Pentium 2 on this. Don't know, I just wondered what to do next. I'm totally in the dark here again still. It's like make no progress, it doesn't matter what I do. There's no clue, really. I think, right, I need to get some software on next, don't I? Let's have a look at the core temperature reported from that slot 1 CPU. That's what we need to do. I think I'll try and find the Dell, I think it's called Open Manage or something, that you could get for these, and we'll try and run that. It's going to be a bit pain getting it on here. What I might need to do is swap over from the hard drive here back to the compact flash card, and I can put some software out on that compact flash card and run it that way. And then I guess if we exhaust options there and we see the CPU temperature is okay and it's not overly hot at all just before it shuts down, the next thing would be to disable it on here, because my theory at that point is there's a component or a trace or something that's intermittent on the board, relates to pin 15 on here, that thermal event occurred and is fake detecting a thermal event. That's a possibility. That might still be a problem though, because even if we disabled it from here, just because the CPU can't generate that signal, it might not be the CPU that's generating that signal, if you see what I mean. I might then have to try and work out where it goes on the board, but I think that's just going to be impossible because of the multi-layer nature, no schematics, BGA chips. I guess the only other possibility is to hack the BIOS then, because the thermal event shutdown thing is, as far as we can see, coming from BIOS level. Yeah, something occurs that raises something in the BIOS, you know, just stops processing, halts processing where we're at. If we could disable it in the BIOS, well, then it would just run forever without an issue until you actually melt your CPU with the thermal event. So we've got two here. So the first one, DD39.5H00.XC. Oh, it would be a WinZip, wouldn't it? I can peek unzip it. Right, don't tell me it needs a disk. What is it with Dell and these stupid flipping things? So now I need a floppy drive connected, which is just, this is just hell, isn't it? It's like trauma, because I don't have any connections free for floppy drives now, because we're using it for the compact flash. So why would it need to be a disk image? Let's have a look at what that other one is. Yeah, that's huge, that. Okay, well, I'll just try running this one. Maybe it'll self-extract, I don't know. Cannot be run in DOS mode. Oh, it's Thermal Shutdown, look. Yeah, and I've got check CPU installed here. See that speed, 497.1, 499. We're getting some variation, which, yeah, you kind of expect with some utilities on DOS. You get a variation, depending on exactly when you run the utility and what the system is doing. Bear in mind we're running DOS, so it's not like we've got parallel stuff going on with threads and things in Windows. But yeah, I'm just going to do this just until, if I see anything unusual. I'm just wondering if the CPU speed is varying too much. Like maybe it goes up to 505 megahertz, 510 or something as it warms up or something. No, look, shut down. Yeah, I'm clutching at straws here. I'm wondering if this fan has something to do with it. But I was looking at this and I saw this little component stuck out here, and it's on a hole. Let me show you. There's a hole in that, you can't see it. There's a hole in the PCB in front of it here, almost like that's detecting air temperature. And it's black. It doesn't look like a capacitor. It's got 10 something on it. Let's have a look. Maybe it's yeah, 103. Is that a capacitor? You'd think that's a capacitor, but why is it on a little PCB stuck out with a hole in it? I think that's air temperature, if I'm honest. Yeah, I pulled that circlip off there. It's, hang on, where is it? I can't even show you. I don't think. It's here. It's just a split ring. So that came off, and then I just pushed the centre bar here through from that side, through that side there, and the fan just released gently. You can see it's very dirty in here though. Look at all the dust and fluff, and that weird thing is there, look. You can't tell me that's not some sensor related to either temperature or RPM. It's got to be. It's got to be. So let's just get a cotton bud with some IPA and have a bit of a clean. I'll get the toothbrush on it and some contact cleaner actually into the fan itself. It can't be detecting RPM though, because, well, this fan's plastic. There's nothing that could gain a signal from if it was, you know, going off magnetism or light, because nothing, well, there's just nothing, no reason, no way for that to detect as far as I can see. So it's got to be temperature. It's got to be temperature. But you never know, maybe there is an RPM thing in here and it can't detect the RPM, so let's just give it a good thorough clean up, get rid of all this dust. Famous last words, it's probably going to ping off now. Oh, like that. Best thing to do this with is a pair of pliers, really, where you're pushing both sides down at the same time. But you've got to, in my experience, put something on top of it like this, because if you don't, there we go, you'll lose it. Let's just try and rotate it if we can. It looks like it's not closed up properly. It's rotating, so that's right. I think because it's nylon, those are a bit separate compared to where they were originally. It's on. It's on. Well, it's a lot looser and it's a lot cleaner. Previous fan failure, that's because it can't take the RPM, and thermal failure. There you go, so we do have the problem still with another P3. Oh, my brain hurts. There's a crazy thought here. I'm going to try a different RAM module. I've got a 64 meg here that I used back in the day with Salomon, I think. So I think this should work. It's just, you know, straight DDR. Yeah, just shut down again with a different RAM module. So it isn't the RAM. So despite the fact this cap is soldered on okay, it looks awful. Look at the solder points there, and it's really funny colour. So I've got some flux on it, and I'm going to just reflow this pad here, and we'll just see. Let's see what happens to it. Oh, look at that, it's doing nothing. Yeah, it is oxidised, isn't it? Well, it's looking a bit better. You can see though, just from heating there, you know, I managed to mark this and remove a bit of the solder mask. I mean, that's still looking dull. It's browny here. And this is the thing, a lot of the solder points on this look browny, but these have all cleaned up a fair bit. And the solder points look okay on them. So I cleaned up some of the components down here. They still look a bit crusty. There's no bad solder points though, just really oxidised. But I figure let's just have a really good clean. Let's get a toothbrush and some IPA and have a scrub. You're going to tilt the board like this and pour quite a considerable amount of IPA down here. I'm going to get right under the socket. I'm going to clean the socket in a minute. Right, this is the following day. It's early days, but I think I might have fixed it. And what I've done is just put a piece of Kapton tape, or actually insulation tape, over one of the pins on the CPU. Now, it's not the one for the thermal shutdown. What it is one of the 4 or 5 configuration pins that identify to the motherboard what voltage rating it needs. And I was thinking back, when I originally looked at the output of those MOSFETs and I saw like 2.07, I was thinking, oh, that kind of looks alright for a chip that runs between 1.97 and 2.07 or something, or whatever it says on the wiki. But the chip actually, on the side of it, it says 2 volts. So I started to think, maybe it needs to be exactly 2 volts, because the steps in between on voltage are so fine on the Pentium 3. In other words, you can, if your chip needs 2 volts, you can set 2 volts. You try and overclock it, you need to increase 2.05 or 0.07 or whatever. But there's a lot of granularity in the steps. It's like point something of a volt, point something of a volt. There's loads of them in the table there, depending on the CPU. So what I did is I found where they go on the board, they go to a 245. There's a chance that it might be faulty. When I said 245, it's a buffer. It's like an LV 245, I think. And 4 of the connections go there. One of them goes to a transistor. But anyway, the one that I was suspecting, when I was looking at the table, for 2.07 volts, you've got, I think it's like the jumper set, and the last one is open. So that last one, I just put some insulation tape to make sure it's open. Well, do you know what? Now it's working. I've just measured the voltage. It's not what I thought it should be, 2 volts. It's somehow now 1.6 something volts. Now, you'd think if that voltage was too low, this wouldn't work at all. That's my thought. And it seems, well, it's just working. It hasn't powered off yet. It's been running for 15-20 minutes. So, do you know what? I think this has been getting overvoltage all along. And I don't think there's anything wrong with the voltage, you know, the VREG side, per se. Maybe it's the 245 that's buffering the jumper settings. Or maybe it's just got the wrong Pentium III chip in it. On the slot itself, you can see you've got these 3 pins here, vid 1, 2, 3, 4, and vid 0, 3. All I've done is put a piece of tape over that one, vid 0, yeah? Maybe vid 3's not making a connection as well, but we'll check that. Vid 0. And if you look at this website here, you can see the pins, vid 2, 1, whatever, 0. And it shows you the core. Now, we've just set, well, I've tried to set to 2 volts spot on. And if you look at the bottom one, can you see it's like ground for 2.05 volts. That's what we had, I think. And I've set it to ground, open. And that open is on vid 0. So how have we got 1.6 volts? This is the mystery here. Unless it happens to have, that tape, gone onto the vid 3 pin next to it. So, yeah, I don't know. I need to look at that. Ah, it has. This explains it entirely. I think I've inadvertently masked vid 3 here. If I scroll across the voltages again and we look down here, we've got 1.6 volts there. And scroll across, look, that one's open, that's the one I've deliberately set open. And then we've got ground. Oh look, open. That's the pin that just happens to be next to where that tape is. You know what, I've masked 2 pins off there. Point is, under voltage in it has fixed it. Putting it at 1.6 volts has fixed it. I'm confident that's the issue. Just got to find reasons why that VREG would be out of tolerance or something. I don't know, it's a bit strange, isn't it? I mean, the fact that we've reduced the voltage to 1.6 volts shows me that those 2 pins are being detected as open circuit, okay? Yeah? So if there were a problem, well, I don't know, this is what I don't get. If there was a problem, you see, well, that doesn't make any sense. That doesn't make any sense at all to me. And no, that didn't solve it. We still got a thermal shutdown. Previous failure, thermal shutdown. Oh joy, even when you under voltage you get a thermal shutdown. Oh god, they're so annoying. I thought I fixed it. They're stone cold, they measure alright. The caps around here have all been replaced. I can't find a power management IC, something that would generate the PWM signals that those need. That's interesting. I've got a crashing doing there. Let's just power cycle it. Could be because the voltage is a bit low. That's just keyboard failure. Yeah, keyboard failure. So other than that first error we got, when it's warmed up, I haven't had another issue, and it's been running for half an hour now. Hang on a minute. Unreliable memory. Ooh. On the motherboard, I noticed 2 555 timers, and I thought, I wonder if they're doing the PWM. And I actually think they might be, because I'm just looking at the range that a 555 will go between 500 kilohertz to, mind you, they go lower than that. They go much lower than 500 kilohertz. That's a mistake. But up to 2 megahertz is the key. So the very fact it's showing 500 kilohertz there is... Now that's the max frequency. Yeah, the switching frequency I'm seeing on the scope is about 100 kilohertz. So you know what, I'm calling it, it's those 2555s that are doing the switching there. So the video was running on in length again there. You may think I'm crazy by including all these random things, and that's the way my brain works. Sometimes I just go off at a tangent at a random angle and learn something, basically, learn something. So like looking at that fan a second time, you know what, I'm pretty convinced that that little thing that sticks out is an RPM sensor of some kind, a Hall effect sensor maybe, because that's obviously the magnetic part of the outside of the fan. It's got different field lines on it. It's going to be a north pole and a south pole at various points as it rotates around. I'm guessing that's how it detects the RPM. So yeah, please join me in the next part where we clean up the mains lead, and hopefully the mains lead will fix it. Thanks ever so much to all the people supporting Coffee, Patreon and YouTube membership. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.